Our planet is in constant motion. One of its most noticeable movements is its rotation on its axis. This rotation is what gives us the cycle of day and night. Imagine Earth as a spinning top. As it spins, different parts of it face the sun. The side facing the sun experiences daylight, while the side facing away experiences night. A full rotation of Earth on its axis, relative to distant stars, takes about 23 hours and 56 minutes. We call this a sidereal day. However, we don't use the sidereal day to measure our time. Instead, we use the solar day, which is the time it takes for Earth to rotate once relative to the sun. The solar day is slightly longer than the sidereal day, averaging 24 hours. This difference arises because as Earth rotates on its axis, it's also moving in its orbit around the sun. This orbital motion means that Earth needs to rotate a little bit more than 360 degrees each day to bring the sun back to the same position in the sky. While Earth spins on its axis, it also embarks on a much larger journey, a revolution around the sun. This journey takes approximately 365.24 days, which is why we have a year. The path Earth takes around the sun is not a perfect circle, but rather an ellipse. This means that at some points in its orbit, Earth is closer to the sun, while at other points it's farther away. Earth's varying distance from the sun affects the length of the seasons. When Earth is closest to the sun, in January, it's actually winter in the northern hemisphere. This might seem counterintuitive, but it's because the seasons are determined by the tilt of Earth's axis, not its distance from the sun. To keep track of Earth's journey around the sun, humans developed calendars. For centuries, the Julian calendar, created by the Romans, was the standard in many parts of the world. However, the Julian calendar had a slight inaccuracy. It assumed a year was exactly 365.25 days long, which is a bit longer than the actual length. This discrepancy led to a gradual drift of the calendar dates relative to the seasons. To correct this, Pope Gregory XIII introduced a new calendar in 1582, the Gregorian calendar. The Gregorian calendar made minor adjustments to the length of the year and the placement of leap years, bringing it closer to Earth's actual orbital period. Another challenge in timekeeping arises from Earth's rotation. As Earth spins, different locations experience midday at different times. To address this, standardized time zones were established in the 19th century. Time zones divide the globe into 24 zones, each spanning 15 degrees of longitude. Within each time zone, the time is synchronized, ensuring that clocks are aligned with the position of the sun. Earth's rotation and revolution are not its only movements. Our planet is also subject to other, more subtle motions. One such motion is axial precession, a slow wobble of Earth's axis. Over a period of about 26,000 years, Earth's axis traces out a circle in the sky. This precession doesn't affect the length of a day or a year, but it does slowly change the timing of the seasons. Furthermore, our solar system is not stationary. It orbits the center of the Milky Way galaxy, completing one revolution every 225 to 250 million years. And our galaxy is also on the move, hurtling through the vastness of space. So, the next time you look at a clock, remember that the seemingly simple act of measuring time is intimately connected to the intricate and awe-inspiring movements of our planet and its place in the cosmos. What if time isn't a straight line, but a spiral around the stars? Subscribe to at Light Leap Labs and journey through the mind-bending mysteries of space, science, and time itself. Like if you've ever felt the pull of something bigger, and drop a comment if you time travel in a heartbeat. Hit that bell so you never miss the cosmic leap into the unknown, because here, time doesn't just pass, it dances.